Welcome back to another episode in CSC 263, Database Management Systems at Adelphi University. Today we'll focus on the SQL language, but rather than last time when we talked about data definition and figuring out how to define metadata structures like tables, primary keys, and foreign keys, in this particular video we'll start looking at what it means to do some basic data manipulation operations. Specifically, how we're going to insert new data into the database, how we are going to retrieve data from a single table, how we're going to make changes to data that is already stored, and how we're going to remove data from the tables. Each one of those commands we'll look at in a little bit more detail, and I'll demonstrate on screen for you as well. Once we've done that and covered those basics, in the next video we'll talk about more advanced querying of data, such as tables including join operations or subqueries and aggregate functions. But for now, let's focus on single table CRUD operations: create, retrieve, update, and delete. As before, we are going to start by logging into the database. And just to review the table we created before, which we called grades, we see that there is a grades table with student ID, course ID, term, grade, and date posted. Now, let's assume that I am student ID number 1, and I'm taking course ID, in this case 263. We're doing that in the fall of 2020, and I am going to get an A- on, I don't know, let's take August 1st as a date of 2020. If I want to capture that element of data into my database, I can use the insert command. So always start the phrase with insert into, the name of the table. Now remember that when we introduced the relational database model, we said that columns don't have an ordering. And that means I cannot just list a number of values, because the database would have no way to figure out which value matches with which column. So first I'm going to list out the columns in the order in which I'm going to provide data, and then I'm going to provide the actual value. So we're going to say we have student ID, course ID, term, grade, and posted. Just like that. The keyword values, and then between parentheses my student ID is 1, the course ID is 263, the term is fall 2020. Now notice that I use single quotes here. Whatever your string delimiter is depends on the database product that you are using. We are using PostgreSQL, which uses single quotes for string delimitation. The grade that I earned was an A-, and the day on which I posted that grade, there's different ways you can specify it, but let's go with 2020 08-15. Execute. Now notice that the database is kicking this back to me. It's telling me you can't do that because that you violate a foreign key constraint, specifically the student ID foreign key constraint, and it's telling me even that the student ID I'm trying to insert is not present in the table students. So this is where you see referential integrity kicking in. I defined it as a foreign key. That means that any value I'm trying to insert here has to already exist in the students table. It does not, so the database kicked it back at me. Let's take a look at the students table instead. Done. And so that's an easy one. It has an ID, a last name, a first name, and an email address. So in order to make sure that I'm not validating the constraint, I can do the same thing here. Insert into students, what? Well, the ID, a last name, a first name, and an email address. And the values of those columns are the number 1, my last name, my first name, and my email address. Semicolon to execute. Oops, typo. Again, thank you Database Management System for letting me know that I made a mistake. So we're just going to fix that and saying insert into students. Insert 0, 1, that's good. That means that we are into the database. Let's go back now and try to insert into the grades again. And now it's telling me the same thing for the courses table, because it's saying, you don't have a course called 263. At this point, I was a little lazy when I defined the courses table. So let's go do that. Insert into courses. What? The ID field. What are the values? 263. So now we have a course 263 defined. And now we can go again. And now it's happy. And my data is inserted into my database. We can double check that by just going select all from students. The star is a placeholder. We won't be using it very often, but when we're doing some quick interactive checking, it's okay to do that. And this is how we query the database. Select all from students. The situation in which we want to list all rows and all columns is rare. It doesn't happen all that often. At this point, especially when we look at the students table, it's not a huge deal. Again, all we have in that table is one row with 4 columns. That's something we can deal with. But if we want to be a little bit more restrictive in our output, we know what operations we have to do that. We have, from the relational algebra, the selection and the projection. Remember, the selection limits the number of rows that is restricted to only those that meet certain criteria. And the projection limits only the columns that are being restricted, and again only to those columns that we are specifying. So let's start by looking at those in SQL. The first one would be the selection. In other words, I'm going to limit only the rows of which I'm interested in, but I'm not going to limit the columns I'm returning. So I might type select all from students, where say the last name is Learner. And at that point I'm still only returning one row. Again, in this database that makes sense because there's only one row in the database. But had I had multiple rows, only those with last name of Learner would have been returned. I could have done multiple selections here. I could, for example, have said and first name equals case. So what we see in terms to do a selection operator in SQL, it happens in the where statement. The where statement limits the rows that are being returned to those that meet criteria. In this case, last name should be Learner and first name should be case. Notice that we're using a single equal sign, even though from programming we're used to seeing this as an assignment operator. Here we're using it as a testing operator, testing for string equality or value equality, I should say. And we're using the keyword and. We could use an or here as well in case if we were looking to have multiple criteria. Now, as interesting as this is, we might be only interested in some of the fields, the projection, and we can do that by just listing out the fields that we're interested in. So, for example, if I'm interested in only the ID and the email address of all students who have a last name of Learner and a first name of Case, this query will do that happily for me, and it will return that as a result set that I can work on down the road. Simple selection, whether it is simple selection on single or multiple criteria, and projection. If we start down the road embedding these SQL statements in programming languages, so higher order programming languages, I always want to see the columns that you are looking for explicitly referenced. I don't ever want to see a select star in those cases. If we're doing some interactive querying on the command line for human consumption immediately, that's fine. But if we're starting to use this in programming, I always want all of those columns explicitly listed so that we have full control over what is being returned to us and the order in which it is returned. Now, we now know how to put stuff in the database. We now know how to retrieve stuff from the database. We haven't made any changes yet to the data, and we haven't removed any data from the database. Let's take another look at the grades table and the data that is in it. Now let's say that I made a mistake and my grade wasn't an A-, instead it would have been a B+. I want to be able to update that grade without having to remove the existing record. We saw that in the data definition language with the alter table statement. Here we can do that with an update statement. So for example, we could say update grades, set grade equals B+. Now be careful, because if you execute this grade now, command now, all grades in the database would be updated to B+, because I have not just restricted it to the set that I wanted to update. Update grades is a dangerous command. If you do not put in the restrictions, it will update all of the fields. It is not a syntax violation to do that. So in this case, we're going to go update the table grades. We're going to set the grade to B+, where the easiest and best way to do that is by just specifying out all the elements of the primary key. So where student ID equals 1 and course ID equals 263 and term equals fall 2020. It does not pay to take shortcuts here. Whenever you're dealing with updates, or as you see in a second with deletes, you want to be as specific as you can, even if you think you could do it with a smaller set of fields. It is going to come back and cause damage. There are no shortcuts. This is how we update. Let's double check to see that all the updates happened, and indeed my grade is now a B+. Last thing to show you is how to remove data from the database. Let's say that I want to get rid of this fact altogether. I can just say delete from grades. Don't hit enter right now or execute this query by the semicolon, because it will delete all values from the database. You have not further restricted it. So we're going to do the same restriction. Take the primary key. Now notice when I do this, I copy and paste, including the semicolon. So as soon as I paste, this will execute. And here we go. Delete 1. Double check. And my data is gone. And we're back to an initial database. And so with that, we have now seen the 4 basic data manipulation language operations in SQL. We know how to add data to the database using the insert into statement. We know how to retrieve data using select, and we've seen a simple select for basically retrieving the full contents of a table. We have looked at select statements that allow us to restrict, to project, and to combine both. We now know how to update data in the database with the update statement, or with the remove data with the delete from statement. And in particular, those last 2 statements, what we tried to point out was that they are somewhat dangerous operations if you do not specify the conditions correctly. In other words, if you do not limit the scope of the operation to only those rows that you are trying to update or delete, the database management system will happily apply your requested operation to just about every row in the database. One thing to point out is that we have done operations only on a single table at this point. If we want to combine data in multiple tables, we have to find a way to do that. We know from the relational algebra that we could do that using things like join operations between maybe as unions or as differences, or any of the other operations that we've seen, intersections. But for now, we have not looked at those yet. That will be the topic of the next video.